All right, welcome back. So right now I'm going to work through a question that is similar to what you would see on one of the tests, and I guess the final too. So it's got a little bit of everything, and we'll do some discussion at the end too. But up until now, as far as this week goes, it should have just about everything that we've learned so far. So let's just get started. Let's get into it. So. Barson Leefer is a well-known downhill mountain biker. However, he's well known for not being very good. He crashes at nearly every single race and seemingly does not know how to ride a bike. His coach, Rod Kimball, has recorded the time it took in seconds. So let's highlight that. So our units are seconds. So time it took for Barson to crash from his last 10 races in increasing order. So that's good. It's going from smallest to largest. Our job is to report. Okay, we want to do a standard 5-number summary, along with the mean and the mode. Okay, so a little bit extra. Rod would also like to see a box plot and a histogram with the mean, the median, and the mode labeled on each. Okay, and the data are found below. So let's take a look at the data. We can see that it's in increasing order. That's good. All pretty short times, right? 30 seconds. We've got about a minute. We got about a minute here. And then we see that this one out here, 187, that's the biggest one. That's the largest one. That might be something of the like of an outlier. Maybe. We don't know until we do a little bit of the math. But that's okay. So, I have not rehearsed this. So, I don't know what this is going to look like, honestly. But that's okay. So I would like to start. You can do this in any order, and I encourage you to pause the video and try it yourself first, and then see if we get the same thing or similar things. I'm gonna start, I think, with. Yeah, I'm gonna start. I guess I'll start with a 5-number summary, then I'll do the histogram, and then I'll do the box plot. The 5-number summary is the thing that takes the most time. It's the most math-oriented, so let's just get that out of the way first. So let's get into it. I've got another blank page here, but first I need to grab this. So I'll see if I can, Okay. Let's see if this works. Whoa. Cool. Dang, technology is beautiful. Okay, cool. So we have all of that here, and that's good. All right, so let's do this 5-number summary first. Let's do the 5-num sum. All right, so what I can do that better. Barely. Okay. So what values do we want to figure out first? Well, the stuff is in the data. The data are in increasing order. So let's do. It's already ordered for us. So let's do the median. Let's do the median first, and then we'll do the Q1, Q3. So actually, I'll just draw this, or write these in the order that makes the most sense. So Q1, first 20, the 25%. The 25th percentile. The median is the 50th percentile. Q3 is the 75th percentile. Okay, and then we have the minimum and the maximum. And we also need the outliers too. And let's also report, let's see, 1, 2, 3, 4, 5, that's good. Let's also report the true, the true min and the true max. Looks like it says mini. Oh boy. Okay. Because they might be different. Recall that when we're making box plots, that these two are excluding the outliers. These two are not. So. That's all cool. So let's do the median first, because that's the easiest process, I think. So I'll zoom this in just a little bit so we can see. And all we need to do, and get your calculators ready too. I'll get mine out. all we need to do is whittle away until we find either the middlemost number or the two middlemost numbers, and then take the mean of that. So we'll cross this one out, and this one out, and this one out, and this one out. So on and so forth. Okay, and then we're just left with these two values. So what we want to do is we kind of want to figure out like the hypothetical middle point right there, the number that divides those two. So how do we do that? Let me get that one. Okay, so all we need to do is we just need to add up these two and divide it by how many there are, so just 2. And that's 104 divided by 2. That's 52. Did I do that right? Let me make sure. 50 plus 64. 114, sorry. And then divide that by 2 is 57. 57. Okay, so we'll come down here, and I'll clean this up in just a second, but we'll write in that our median is 57 seconds. Very important to write down your units. Very important. Okay. All right, so that's cool. So we know that the median is 57. It's right here. It's the middle point that divides this whole thing in half. And then let's just find the median for Q1 and Q3, right? For the first half and the latter half. And the process is the same. All we need to do is whittle away. Okay, so Q1 is going to be this 44. So 44 seconds. That's cool. Okay, and then, and then, whoops, do that again. Same thing, right? Whittle away. Here we are. So our Q3 is 70 seconds. Cool. All right. Easy enough, right? And then since we're here, let's report the true minimum and the true maximum. So the true minimum over here is 30 seconds. And our true max is this 187 seconds. Okay. And then now what we want to do is we want to let's find the outliers next. So we're going to find these guys. Just so we can have an easier time getting our minimum and maximum excluding the outliers. Okay, so how do we do that? Well, let's kind of divide. How do we want to do this? Let's divide this like so, and just kind of work over here in the margin. I don't care how you organize your work, so long that I can see it, kind of see what your process is. Just as an aside, statistics is a lot about the process, not necessarily what you get at the end. Sometimes, it does matter what you get at the end, but I really more so care that your process looks good rather than getting the same exact answer that I get. So, just an aside. All right, so let's figure out the outliers. Let's figure out the small. Let's figure out the small outliers. All right. And recall that the formula for that is nothing too crazy. We just want to take our Q1, and we want to subtract 1.5, right? Totally arbitrary number. That's just what we do. When we get into the further lessons, that'll make a little bit more sense. But for now, it's just a number. And then the interquartile range. Okay. And if we simplify that, let me not do that. But if we simplify that, that's Q1 minus 1.5. That's all the same. And the interquartile range, the IQR, is just Q3 minus Q1. And it's easy as that, right? And we already have all of those values written out. So let's do that. Let's just plug and chug, right? So we have Q1. That's 44. Okay. And then minus 1.5. And then Q3. Let me do this first. Q3 is 70 minus 44. Okay, so we'll get the old calculator out. So let's see, 70 minus 44, that's 26. So I'll write that here. I'll just show you every step, so we're all on the same page. 26, cool. Okay, and then so 26 times 1.5 is 39. So that's cool. Okay, And then 44 minus 39 is just 5. Okay. And that's it. Oh, no, that's the wrong thing. That's what I want to do. Okay. So anything below 5 seconds is going to be an outlier on the small end, right? On the smaller side of things. Already we don't see that. Okay. So already we don't see that. So we can go ahead and, well, we'll fill that in later. We'll fill in the min and the max later. Let's move on to the large outliers. So the process, again, is still the same, just with a slight change. So for the large outlier, very similar formula. It's, let's see, it's Q3, and then instead of minus, it's plus 1.5 times the interquartile range. Okay. And already, again, we have a lot of that information available. So we'll just go ahead and do that. So that's going to be, let's see, not 44. It's going to be 70 plus. Now, what I'm going to do here is I'm just going to take, since we have already done the work for this part, I'm just going to take that value, right? Because it's all the same. So it's, I'll even denote it with this purple color, plus 39. Okay. And 70 plus 39 is 109. Okay, so let's see. 109. Okay, we'll highlight that. Again, wrong button. Sorry. Okay, so that's 109. So anything above 109 is considered an outlier. All right, look at this. Look at this. We've got one. 187 is above 109. So that's going to be considered an outlier. So let's go ahead and write that down. So 187 seconds is an outlier. Okay, so that's cool. And then we can go ahead and fill in the minimum and the maximum. So that's excluding these outliers, right? So our minimum here is 30 because we don't have anything below what our outlier says here, what our small outlier says, right? So that's just going to be 30 seconds. Okay, and then our maximum, excluding the outlier, right? We know that 187 is an outlier, so we'll just go down to the next one. That's going to be our maximum. Here, excluding outliers again, 71 seconds. So I know what you're probably thinking is, dang, this minimum and maximum thing can be kind of confusing. What are we supposed to report? I will tell you which one to report. So for now, well, another quick step back. The 5-number summary in statistics typically is, well, it's always Q1, median, and Q3. And then usually it's the true minimum and the true maximum reported. However, when we're making these box plots, which we will in just a second, this 5-number summary, we know that the true minimum and the true maximum typically aren't reported. Instead, it's the ones excluding the outliers, right? So just sort of the long and short is that I'll tell you which ones to report. And oftentimes, it makes sense to kind of report both. So, hopefully not too much confusion there. I know that it can get a little tricky, but that is okay. That is okay. So anyway, this is our 5-number summary here, but we also need to add in just a couple of other things too. I believe that Rod asked for the mean and the mode too, so we might as well just write that down. And I'll even sort of divide it up here. Let me do it like this. Okay, so this is our true 5-number summary, what we're going to be using for a lot of stuff. This is some extra information. And then let's divide it up again and put the mean and the mode on there too. Okay, so the mean, not too bad. All we need to do, recall, is, I'll put this work over here too. The mean, all that is the sum of all the x's that we have from the first one to the last one, and then divided by how many there are. Okay, so in that case, all we need to do is add up all of these and then divide it by 10, which is how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. Okay. Also, this will probably take just a little while. This video, I promise you that when you're doing this on your own, it won't take as long as I'm taking here. I'm just trying to be as thorough as possible. So, the mean in this case, all we want to do is add them up. So 30 plus, and you can fast forward through this too. 45 plus 50 plus 64 plus 64 plus 70 plus 71 plus 187. Okay. So I'm pretty sure I got all that right. Always double check. Looks like I did though. Okay. Cool. So that sum here is 668. So let me write that out. And we know that we have 10 things. So all we need to do is do, let's see, the mean is 668 divided by 10, which is, you just move the decimal over. So that's 660, or 68, 66.8. Okay, so I'll highlight that too. Okay, so the mean is 66.8 seconds. And let me actually, so that number is right, but let me do this in a different color. So we have some nice colors going on in our figures that we're about to make. So that's 66.8 seconds, and we'll just leave it in the decimal. We're not going to round it up, so that's fine. Okay, and then the mode, do a different color for the old mode. Well, let's see. What we're looking for for the pure mode is just the most frequent number. And since we have discrete values, right, so whole numbers here, there's a chance that it might show up, right? Which in this case, it looks like 64 is the one that shows up twice. It shows up twice. It's the only number that does show up twice. So looks like that's going to be our mode. So that is 64 seconds. 64 seconds. Cool. It looks like we've got everything we need, I think. Q1, Q3, min-max. Cool. Also, if we're trying to be very specific, this should be right here. But that's okay. That's okay. We've got it all. We've got it all there. So that's fine. We've got the outlier. Okay, we got the true min, true max, the mean, the min. Okay, perfect. Okay, so then we've already got the 5-number summary. Sweet. So let's get a new page here. Let's get a new page. Oh, nice. All right. And let's bring this over. Oh, no. Cool. Copy. Paste. Cool. So I'll put that up there in the corner for us to reference. So it looks like that's, yeah, it looks like that's good. All right. Cool. So we don't touch it. Okay, so I think I said I wanted to do the histogram first, just because we haven't done that in a while, so let's just go ahead and do that. So I will draw out, I'm just going to draw a line here that's going to be our x-axis, and then I'll draw let me make that longer. There we go. So that's going to be our x-axis, that's going to be our ranges of values, and this will be, our y-axis here will be the frequency. So we know that if we're trying to be very specific, which I think in this case we are, let's put our units. So it's actually time to crash, right? TTC. And this is in seconds. Okay. And then frequency is on our y-axis. I'm just going to do a capital F for that. Just so we're not wasting space here. All right, and then after that, we just want to make our table to organize things in, where this is going to be our bins, and this is going to be our frequency. What letter is that? Frequency. Okay, cool. So how many bins do we want? I I don't know. I don't have a preference. We have, and now that I think about it, I think I want this too. Great. We'll just put that right there. Whoa. Bear with me. Bear with me. What is happening? Oh my gosh. Why is this not working? There we go. Cool. Great. Okay. In fact, I'll just move this down here too. Okay. So, how many bins do we want? How do we want to see this histogram? We have 10 values, so I'm thinking maybe 4. You can try something different. It's totally fine. But since we want 4 bins. You want 4 bins. Let's do, yeah, I think 4 bins is fine. So let's just figure out how each range of values is going to kind of shake out. So all we need to do for that, recall, is subtract the biggest value from the smallest value, right? So our true minimum and our true maximum. So that is going to be the true, I'll just write it out first. The true max minus the true min divided by then the number of bins that we want. Number of bins, which in this case is 4. So just kind of keeping that as a note over there. Our true max was 187. So it's always a good idea to write out everything you know. So it's 187. And then our true min is 30. And then divide that by 4. That's not the right green. There we go. Okay, and then if we just get out our handy-dandy calculator, I'll do that real quick. So 187 minus 30 divided by 4. That's, let's see, 30, let me do it in this color, is 39.25. And recall that when we're doing this bins, 39.25, that's kind of difficult to work with. Always round up, or always rounding up. So thankfully this goes up to 40, which is a pretty, is that right? Yeah, that is right. It's going to be pretty big. That's fine. That is okay. Seconds. Yeah, that's right, because we have this really big value here that we have to include somehow. Okay, so because of that outlier, our histogram is going to look kind of funky. But that's okay. That is okay. So what we want to do here then is just figure out our range of values. So we're going to start at 30, and then we're going to add 40 to that. Okay, so that is going to be 70. And then 70 from 100, let's see, 70 plus 40 is 110. And then 110 plus 40 is 150. And then 150 plus 40 is blanking 190. Okay, so that's fine. That's good. Now recall that this, when we're looking at these bin lengths, right? We go from this value, from the starting value, up to the next value, up to 70, but not including 70, right? Not including 70. And then 70 up to 110 and not including 110, et cetera, right? Okay, so then all we need to do is figure out how many times these values show up into the bins, right? So we've got 30 to 70. That's going to be a big chunk. That's going to be a big chunk of our data. So that's fine, though. That's okay. So we've got 1, 2, 3, 4. Let me do this too so you can see me count. 1, 2, 3, 4, 5, 6, 7. Now, our ending point here is 70. And we see that 70 shows up. But again, we're not including 70 in this. That's going to be in the next one. Okay, so 1, 2, 3, 4, 5, 6, 7. It's going to be a lot. It's okay, though. So that's 7 times. 70 to 110 shows up, 70, and then 71, okay, and then, so that's just 2. 110 to 150, now that doesn't show up, right? That does not show up at all. And then 150 to 187, or to 150 to 190 is 187, which shows up once. Okay, so we're gonna have a weird looking sort of thing here. Okay, so that's fine. So what we want to do then is come over here and just lay out our ranges of values. Let me scale this just a little differently. Okay, so 30 to 70 to 110. I'm just grabbing these values from down here. 150 and then 190. Okay, and then so our maximum frequency is 7. So that's going to be 1, 2, 3, 4, 5, 6, 7. 7, 6, 5, 4, 3, 2, 1. Cool. And then, I guess 0 down there too. All right. So then all we want to do is just count. So we have from 30 to 70. From 30 to 70 down here. We've got that showing up 7 times, right? So that's just going to be up and over, up until 70, okay? And then 70 to 110 shows up 2 times, so it's going to be like this. All right. 110 to 150 shows up no times, so we will leave that alone. We will leave that alone and not put anything. We'll just have a weird sort of space there, and it's okay. It's okay that there's a space. Okay, and then 150 to 190 shows up only 1 time, right? So we'll just put that right there. Looks like that. And then if we're trying to be fancy, and I think that it kind of helps, we'll draw that sort of smooth line over it so we can see the shape a little bit better. All right, but even though it's like fairly obvious now. Okay, so that's our histogram, but I think that we need to label the mean and the mode and the median too. Okay, so thankfully we've already done that work. We've got it over here. So this is good. So the median, we'll start there. The median is 57. Now you can eyeball it. I'm not going to be judging or grading on like how close you get it. So I would guesstimate that 57 is like maybe right about here, right about there. So what I'm going to do, and again, there's no standard on how you label this, which is fine. So we'll just do this, and then I'll kind of make a little arrow right here. That's the median. So that's the median. And we'll just put in quotation marks that it's 57 seconds. Okay. So that's cool. And then the mean is 66.8 seconds, so a little bit larger. We'll put that back in its green color here. So we'll just say something like this, thereabout. Okay, and then that's the mean, 66.8 seconds. Okay, and then the mode is 64 seconds. So just sort of right. They're all right here, right around the same value, which is pretty cool. Which is, what do we say, 64. 64 seconds. Cool. Okay. So that's it for our histogram, right? Now, if you just pause the video and tried it yourself and used a different bin number, then you might have something that looks a little bit different. The sort of rule is, you don't want to do, you don't want to do a bin for each value that you have, because then it would just look, it would look like this. Everything would be the same height, because there's just one of each. But depending on how many bins you chose, you might get something that looks a little different, but the story should be about the same. We would say, and then if we're trying to be very fancy and very thorough here, let's zoom it in. Which, this is certainly not a normal distribution, right? This looks a little bit funkier. It's not symmetric. It's not bell-shaped, right? We know that. It's got one mode, right? So it's got one range of values that shows up the most frequent. So that's fine. What we would say here is that it's skewed in some direction. And which direction is it skewed? Okay, a little tough, right? A lot of the data is over in the left of the figure, but there's something over here that's pushing the data over that way. Something in the right of the field pushing the data this way. Okay, so that means that the data are right skewed. So what we would say is, let's see, TTC, time to crash, are skewed right. Okay, so we'll put a little box around that. Wonderful. Okay, so TTC are skewed right. The data for this is skewed right. Okay. Again, small data set. We only have 10. I won't make you do anything larger than that, probably. So that's all fine. That's all good. Okay, so we've got the histogram. Let's see. We've got it labeled with the mean, the median, and the mode. Okay, we got the 5-number summary. So let's do the box plot next. Okay, so what do I need? I think I only need the 5-number summary in this case, right? Yes. Oops. Okay. So bear with me for 1 second. Just copy this over. Cool. Put that right there. Zoom it. Come on. Cool. Okay. So then, what do we want to do? How do we want to do this? Let me draw this, our x-axis here, because we only have one x-axis. And then I guess it would help to have the data. So let me just throw it up here too. Cool. Okay, that's cool. Easy enough. Okay, so what I want to do is I want to label the axis here in even increments, right? So I'm just kind of looking at it now, 30 up to 40. We have a big jump up to 187. So I'm thinking 30 and then 60. Maybe if we do units of 20, that should be manageable, I think. So 30, and then that's our smallest value, and then what did I say? 20. So plus 20 is 50, plus 20 is 70, 90, 110. Oh man, I think I might run out of room. What the heck? 130, 150, I'm gonna have to draw it out a little further. 70 and then 190. That's fine. That's decent, I think. All right. So it's not the straightest line, but that's okay. And then all we need to do now is just draw it out. We already have everything we need here. We really don't have much work to do now. So that's fine. Let's start with the median, okay, because that's just a straight line. So that's at 57. So that's right about here. Right about here. Only guesstimating too. And then Q1 is 44, which is right about, let's see, so 40 is right there. So maybe like right about here. Okay. And then our Q3 is 70. Look at that. That's easy to find. Right there. And then we'll just connect the old dots right there. So that's cool. And then we want our minimum, and we want this minimum. We want this one that's excluding the outliers, even though that the minimum excluding the outliers and the true minimum are the same value. We want the one that excludes the outliers. So that's 30 seconds. Easy enough, right? We'll just put that right here. And we will connect it with a line. So it looks like that. Okay, and then we want the maximum excluding the outliers, which is 71. Oh, again, that's pretty easy to find too. Right about there. Okay. All right. And then we just want to throw in our outliers too, which we already have. We know that 187 is an outlier, and that's way over here, right? So we'll just put a dot right out here. Okay. So we see here we're almost done with the box plot, but we see here that, this box plot and our histogram here are kind of showing the same story, right? We're able to see a little bit more information regarding this guy, right, this 187, and we're also able to see that, there's this whole kind of thing right here is being reflected right here too. And then this bin right here only represents one value, this 187 we saw down here. Same deal here, right? So again, I think that the box plot tells you a little bit more information, but the histogram is able to show you the shape a little bit better, right? Okay, so that's fine. So let's label this here. That's the median, and we'll just put the value in there, 57 seconds, right? Okay, and then we just want the mean and the mode next, and we'll just do the same sort of process, right? So 66.8, that's right about, gosh, like right about there. And we'll just denote that with actually, let's denote that with a star, like so. That's usually what it is. And we'll just come out here and say that's the mean. And that's 66.8 seconds. Cool. And then the mode, 64, we'll do that as a dot. And it's just super close, right? It's like right about there, right? Okay, so just do this kind of thing. Mode, 64 seconds. Oops. Cool. All right. And before we move on, I think that's it. 5-number summary, check. The mean and the mode, got that. Box plot, histogram, mean, median, mode. Yeah, we've got it all. We've got it all, and everything is pretty consistent too, which is good. Everything is kind of telling the same story, right? So, well, what else? Well, we're pretty much done. We've asked, or we've done everything that Rod asked for, Rod Kimball. But let's talk a little bit more. Let's talk about kind of population and sample conversation. So the sample was 10 times randomly chosen. That's cool. But our population, so, if we were to do some statistical test on this, which we're not, but if we were doing some statistical test on this, or trying to sort of do some inference here, who can we apply this to? Can we apply this to all mountain bike racers who are maybe as equally as bad? Maybe, if we're able to kind of quantify how bad they are. But for right now, we'll assume that, Barson, has raced more than 10 times, right? So we'll say that maybe he raced 100 times in the last 2 or 3 years or something. That is the population that we are able to sort of apply these findings to if we were doing inference, which we're not. But in this case, it would just be Barson Leifers times, I'll say race times, and that's it. That's it. Period. Okay. So the sample is just these 10 race times that were randomly chosen, and we'll assume that they were properly chosen too. They weren't like, all the ones at the end or something like that. And the population that we can apply these findings to, if we were doing inference, which we're not, we're only doing the descriptive stuff, but would be Barson Leifer only, right? Only his race times. And actually, if we're trying to be more specific, let's say this: race times in, downhill mountain biking, MTB. Okay, so he might do other types of races too that he might be better at. We just don't know. We don't have that data, right? He might be worse too. We're only able to apply it to specifically Barson and specifically that sport, that downhill mountain biking sort of environment. Okay, so I think that's about that. So if you're watching this and we got similar things, great. If we if we didn't get similar things, that's fine. Send me an email. We can go over what's going on. If you feel like you've got a good handle on this, then you're going to be set up pretty well for the test and for the homeworks and such. There'll be quite a bit of this on there. It won't take as long as I took for this. I'm just trying to be as, detail-oriented as possible. But it looks like we've got everything we need here. So what I'm going to do, pause the video, or I'll stop the video, and then try it out yourself. You have the answers now. And hopefully we get similar things. So I will see you next time.